In this video, we'll be covering Chapter 2, Section 2, over subsets. Okay? Set A is a subset of B. That is going to be notated by A subset of B. This notation means it's a subset. Okay? If every element in A is also in set B, then we have a subset. If we look at the set A, we have the numbers 1, 3, 5, and 7. If we look at set B, we have 1, 3, 5, 7, 9, and 11. If every number in set A is also in B, then we can say set A is a subset of B. So 1, 1, 3, 3, 5, 5, 7, 7. So we can say A is a subset of B. Okay, let's look at the next example. Set C and set D. Set C has numbers 1, 2, and 3, while D has 1 and 2. Notice in this case that 1 and 2 are in both C and D, but 3 is only in C and not in D. Since all of these elements are not located in D, we would say that set C is not a subset of D. Notation would be the subset sign with the line going through it. This next part is we're going to write if this is a subset or not a subset in each blank. Okay. So if we look here, you will see the numbers 1 and 1, 3 and 3, 5 and 5, but 6, 9, and 11 are not elements in this set. Therefore, we would choose the not subset symbol. For B, it says X is the element where X is the letter in Ruth. So here, this is that set notation. It has the elements R, O, and F. This other set says element Y, where Y is a letter in the word proof. So in this set, we have the letters P, R, O, and F. Since the letters in Ruth appear in proof, then we can say that this set is a subset of this set. The next section is over proper subsets. Set A is a proper subset of B, expressed as this. Notice that the difference between this and a subset is that there's no underline underneath the symbol. Okay? If A is a subset of B and set A and B are not equal, then we have a proper subset. Okay? If I look at these two, set A and set B, I can see that the numbers 1 and 3 are in set A, 1, 3, and 5 are in set B. We can say that set A is a subset of B. Okay? Since these are not equal, we can say that it is also a proper subset of B. Remember, not equal means that there are different numbers of elements in each set. Here we have 2 elements in set A, and here we have 3 elements in set B. However, if we had an element where set A was 1, 3, and 5, and set B was 1, 3, and 5, we can see that yes, set A is a subset of B. However, because set A and set B are equal, they would not be considered a proper subset. You cannot use this symbol. The best way for me to explain the difference between a subset and a proper subset is to use something that we already know. Let's use the numbers 3 and the number 5. If I use the symbol 3 is less than 5. Would this be a true statement? Yes. Would it make a difference if I put an underline in here? Now it says 3 is less than or equal to 5. Is this still a true statement? Yes. This is similar to a proper subset.
As both of these statements would be true.
Let's look at another one. If I had 5 and 5, but if I put an equal sign underneath, then I can say that this is a true statement. But if I take away that equal sign, I can see that this is not a true statement. This is not the correct way to indicate an inequality. The way we would write this is we would write it as 5 is equal to 5. We would not write 5 is less than or equal to 5, even though this is a true statement, it's not in the proper form. So in other words, if the set A is less than the set B, we can use a subset and we can use the proper set. If they are equal, we cannot use the proper subset sign. We only can use the subset sign, which includes the equal because these two are equal while these two are not. Let's look at some examples. Okay, here we have two sets. We have a 2, 4, 6, and 8. Here we have a 2, 4, 6, and 8. This one does not contain a 10. This one does contain a 10. Okay, so because this is a proper subset, I can use this symbol. I can also use this symbol here. That means if I can use both, I'm going to write both. Both is true. For part B, it says X is an element where X is a person and X lives in Atlanta. In your second set, it says X is an element where X is a person and lives in Georgia. Well, in this particular case, if a person who lives in Atlanta is definitely going to be a person who lives in Georgia. But all the people who live in Georgia do not live in Atlanta. So this statement is both a subset and a set. If it is both, we write the word both. Determine if the statements are true or false. 4 is an element in this set which contains 4 and 8. This is going to be a true statement. Okay, 4 is an element and it is in the braces. This set is a subset of this set. Since this is saying it's a set and the element 4 is also in this set, then this is going to be a true statement. Okay. C, this set is not an element in this set. Remember, when it has the braces, it is referring to this as a set, not as an element. So this is actually true. We're going to let A equal an empty set and B equal this set, which contains the element of 6, 7, and 8. Is A a subset of B? Is this element in this set? The answer is yes. The empty set is always a subset of any set. Empty set as a subset. For any set B, an empty set is a subset of that set B. For any set B other than the empty set, a proper set. Okay, so an empty set is a proper subset of B. Remember, as long as these two are not equal, it is considered a proper subset. Okay. Okay, so the number of subset in a given set, all right? So if we have an empty set, we have no elements, okay? The list of all the distinct subsets. Remember, subsets are part of the whole set. Since there's 0 elements, there's only going to be one subset. And we can use the power of 2 to number of elements, okay? So the reason we're using this equation is because 2 means you either have it or you do not have it. Okay, I'll explain it as we go into the next one. The second one, we have one element, A. So the number of elements is only 1. If we're listing all of the distinct subsets, okay, you can have A, which is this subset here, or you can have no elements, which is this subset here. We have 2. You either have it, the A, or you do not. So there are 2 distinct subsets, and it follows the power of 2. 2, and there's only one element in this set, which means there's 2 possible distinct subsets. Okay, let's continue. Here we have the set with the A and the B. There are 2 elements in this set. So let's say we do have the A and we do have the B. This is considered a subset. Let's say we have the A but not the B. This is a proper subset. Let's say we do not have the A but we do have the B. This is also a proper subset. Or we can have neither the A or the B, which is our empty set. This is also a proper subset. So if you can see here, we have 1, 2, 3, 4 possible subsets. If we use the power of 2 rule, we'll use 2 raised to the second power because there's 2 elements here, 4 subsets. Okay. Let's go ahead and look at this next one. We have 3 elements in this set, so I have 3 here. That gives me this subset here. You can have the A and the B, but not the C. That's this subset here. It's a proper one. You can have the A and C, which is here. You can have the B and C, which is here. Or we can have the individual elements of A, B. It's also possible to have no elements in the set. So if we have 3 elements, if we use the power of 2, we'll have 2 raised to the third, which comes out to 8. 1, 2, 3, 4, 5, 6, 7. Remember that the number of proper subsets with n elements, meaning however many elements you have, is going to be the total number of subsets possible minus 1. This minus 1 is referring to the only subset where these are equal. So if I have the power of 2 rule and I wanted to know how many proper subsets I have, I would always subtract the one that has an equal subset. Okay, so here it's equal. These sets are equal. That's not proper. The other 7 are. Over here, this is not proper because they're equal. The other 3 are. So you're always subtracting one set from your power of 2 rule. Okay, let's find the number of distinct subsets and the number of distinct proper subsets. So here I would count how many elements we have. We have 1, 2, 3, 4 elements. So the number of subsets would be 2 to the 4th power, or in other words, 16. The number of proper subsets would be 16 minus 1, and I would get 15. Part B says x is an element where x is a natural number, and x is greater than or equal to 3, and less than or equal to 8. Okay. Let's write down in roster form which numbers meet both of these criteria. Remember, the word and means it has to meet both. Okay. So we're going to start with 3 since x is equal to 3. Numbers that are bigger than 3 but less than 8. That's 4, 5, 6, 7, and then x can also equal 8, so I would include 8 in my roster form. Now I'm going to go ahead and count the number of elements. We have 1, 2, 3, 4, 5, 6 elements. So the number of subsets would be 2 to the 6th power, which is 64. Okay, let's go ahead and do that on the calculator. I will be using the TI-30X2S on all my videos. Okay, so we're going to do 2 to the 6th, 2 raised to the 6th power, which gets me 64. The number of proper subsets would be -1, so I would have 63. A set that is not finite is called an infinite set. Okay, so an example is this set where x is an element of a natural number and x is also divisible by 3. Okay, so the very first number we would have is 3 is a natural number and it's also divided by 3. Then we would have 6, natural number, you can divide it by 3, 9, 12, and so forth. This will go on indefinitely, therefore it is an infinite set. Okay. Here's another example. We have x is an element where x is a natural number and x is less than 8. Since natural numbers begin with the number 1, I would have 1, 2, 3, 4, 5, 6, 7. This states that x is less than 8, not equal to 8, therefore I have to stop at 7. Here we have a specific number of elements in this set, therefore it is a finite set. This concludes the lecture for 2.2. Let me know if you have any questions.